Do you read science fiction?
Yes.
Yeah.
Do you watch Foundation? Do you watch Foundation?
No,
No,
Do you read Isaac Asimov?
no.
no.
When I was a teenager, I read his, it's not a novel, it's like a short story. And the name is Day of Knowledge. And in the far, far future, there are kids are staying with parents, having fun. And then on the Day of Knowledge, they are coming to the building that is called school. Everyone is pulling a helmet on. It is connected to some computer. And then they get education, they learn how to read, write, calculate, and then another 5 years, they just,
Have to redo it.
no, they just do having fun with parents. Then next time they're coming middle school, they're programmed knowledge again, and then high school, they're programmed everything is needed, and next day after programming the knowledge, they're just passing exams to profession, whoever they do.
Should we do it like that?
But then he's not so straight and simple. The main character wanted to fly to stars, and he failed an exam to be pilot. Then he decided to be like a steward. He failed the exam. Then he decided to be like welder on the and also, and he decided maybe something is wrong with the system. Maybe when they program us through this buckets on the head, it doesn't work. And he noticed that there are like all these buildings were shiny, new, and there are little old buildings and old people that do not look nice with beards coming there and do something. And he noticed it's called library, they're sitting and writing something. And then he realized that those people are creating programs to program other people. And he just went there and found his happiness. I don't know if he became a star player, but it's like interesting thing. But I would prefer today's lecture being programmed with the body. It's a little effort, not on your side, but on mine as well. But clock is ticking, so I'll try my best.
What if you could make that kind of program in MATLAB?
Oh, that's our Wednesday project.
So we need to do a little mental. So future time x summation by and we can replace ph onto k, right? And then it will be e to the power minus I ax. And then there is a label. Summation, there is an infinite number of this ck, therefore we replace integral over dk from k minus infinity to plus infinity. And then we have expression for this ck, which will be square root by sigma e to the power sigma k by 4, something like this. This is a plane wave minus I x, and the energy is minus, I missed here, e to the power minus I is bar et. So last
So the matrix.
time, just a second, t, last time when we met, we replaced it to the p squared whole square m, and if our this is definition of k, then k is h bar p, right? H bar squared p squared to m. So integral dk square root by sigma here square minus sigma k squared 4 e to the power minus I p x on the side h bar squared h squared to m, and here is a g. 1k cancels, not h cancels here and there, and we need to take this integral. So no science on the how do we take it?
Oh.
Any question?
Oh, I was gonna say you lost me, but you got me that.
Okay, thank you. So, what is this integral? What is the independent variable?
Okay,
K. What is the most senior power of K?
It's squared.
Okay, so if we learn how to take e to the power minus k squared, dk,
Use over 2, but when you do the integral, it's gonna end up being over 2.
first,
Yeah.
first we need to look here. There are constants. There is another power-free term. So there is nothing. Huh?
Pull out whatever doesn't have K in there.
Yes, but still it has this one. So it's a little challenge. But if we will know how to take this integral, we will be able to do the rest. Right? This is this integral is not possible to take as a in definite if when you can take only with the limits.
Yes.
Do you know the answer?
Well, if it's negative 2.
Have you seen the answer? Maybe
I have. It just.
what is proportional to? I'm forgetting constants and but is it like what? What's the answer? No, it's not zero. So Gaussian shape, k from minus to plus infinity shape and the Gaussian shape. It's area.
one,
Yeah, it's close to one, maybe by factor of something, but yeah. No, the answer should be square root of pi,
oh,
which will be a little more than one, right?
Yeah.
But I would stop respecting myself if I just go immediately here. We need to spend at least 10-15 minutes to prove this, and you will enjoy it. This is something you can feel time when you will need to teach any like freshman physics, freshman chemistry, calculus, 1, 2, 3, up to like any time in college. So how to take this integral?
you said,
I don't think you use because there's no. Like if you
well,
have,
couldn't you just take u equals negative k squared?
no, because then what's your du gonna be?
Negative 2k.
Where are you gonna get the K?
It's dk, right?
But you need to do 2K dK. You can't just use up something if you don't have like.
If there would
K
be,
is independent.
if there would be one more k here, then we all would take it happily, right? We would submerge k under the k and then do what you're telling. But there is no k here, so
You can't use that. That's what it means.
it's
You're
really
missing a variable.
it's not very complicated, but it needs thinking out of the
Trixo?
box. Huh?
Trixo?
To each one.
Trix, that one.
We're not setting it for homework, although I would be really happy to see your attempts to invent perpetual mobile and take this integral. It's a really good homework. But let's do it here. So it needs thinking very much out of the box. Using geometrical argument. So let's try to take the e to the power minus x squared dx,
Yes.
and call it ix.
It's basically just.
Let's take square of this. Let's call iy integral e to the minus y squared dy. They should be equal, right? Ix equals iy.
Okay.
Right? If we take ix times iy, take square root of it, it will be equal to our original integral that we need to find.
Okay,
Okay,
okay.
you believe me?
Yes, that does make sense, actually.
Okay, thank you. Now, how do we represent this thing geometrically? How do we like product of two integrals? So I x times I y is integral e minus x squared dx e minus y squared dy, which is integral e minus x squared plus y squared dx dy.
So
Did I lie?
no, that makes
Not
sense.
yet. Okay.
Hey, you might have.
No, I
Okay.
think that makes sense.
Okay, so if we are living on a two-dimensional plane, x and y, so what is x squared plus y squared?
R squared.
Okay, r squared. X, y. So it is e minus r squared dx dy. Two-dimensional integral over the whole space. What if the so dx dy are element of area? Yes.
Yeah.
Here is the next step for thinking out of the box, and I do not take credit for it. I just memorize it and pass it on. If we do have radius, this r squared, and nothing else is under integral, can we swap from rectangular to polar coordinates?
Yes.
Yes. So what is the element of area in the polar coordinates?
Area in polar coordinates is gonna be.
Radians.
Yeah.
So dA in polar coordinates where we have angle and radius.
Are you asking?
No, well, anyone who.
R is side.
So it is d.
Oh. For polar, it's Jacobian just R.
Is it just?
Yeah, and like, if you get to spherical is where it's the R squared.
It's rho squared.
Or yeah.
You guys were studying well. I'm impressed.
Yeah.
You know terminology and that's okay. So
We just have a really good calc professor.
Yes,
so
as
the,
bosses I will do.
it's kind of
Already theta?
gr and d phi, right? So the increment of the angle,
Yes.
right? And not dl, length of arc length for this. Then it will be approximately rectangular, right? dr over dl. And what dl, and how do we express dl in terms of d phi? If the whole circle is 2 pi radius, and if you take dl, then it is 2 pi d phi, right? So element of area will be dr 2 pi d phi. Any attempts to? Anyone is welcome to join.
Come. I feel like they're watching the fourth squad right now.
Okay, so any objections on this one? Oh, you pronounce it as phi.
5 feet. I dropped it.
My calc professor always said the,
What's his name?
Catalan.
Yep.
This is five, right?
So you can replace the integral here as integral dr integral 2 pi d phi e to the r. You lost your chance to get extra point to correct my error.
Oh.
I'm just writing everything down, sorry. Hey, we were talking about adding the Jacobian.
You are, yes. And since we processed the element of area, either by your advanced differential geometry or just by basic arguments that two coordinates. So we get this two d phi over r. Okay, another what I corrected myself. Okay, d phi times r is the increment of arc lengths. And then element of area is dr r d phi. So dr r d phi. So you are either stressed because it's too much information, and therefore there is no time to catch my errors.
I'm just writing up.
Yeah. So look at here. When we just looked at the original integral, we were missing this linear power of the independent variable so much. Look here, e to the minus r squared times r.
Yes.
Can you take this integral? You are.
Yes,
Yeah, because now
because
you
this one's
use
in.
the R squared.
Yeah.
Exactly. So we take, and the limits, the r changes from 0 to infinity because there is no negative distance from origin, and angle changes from 0 to 2 pi. And then this integral 2 pi d phi immediately results in,
Question,
yes,
when you changed your e to an r squared, would the dx dy not just become dr?
once again,
When you change your dx dy, like your x squared plus y to r, does the dx dr or the dx dy not just become dr?
It's a
No,
double- it's a
it
double
becomes-
integral.
dr times r times d phi. Okay. So I feel I need to erase something.
So.
I'll probably erase this thing because we kind of know what it is, right?
Right.
Thank you.
My question, I guess, next is, if we're separating, when we.
Right, I agree with you. So we already get 2 pi from the integral 0 to infinity, e to the minus r squared r dr. Now, what? Again, I'm focusing on the wrong. So please try taking this integral, and volunteers can go and try. Someone,
Well,
you guys can do it.
I think I have it.
my question is, and this is just off of what we learned, so it might just be a difference in writing, is, would we not put this portion in with the dr? Because we're technically integrating in terms of r,
Okay.
not just.
The order of appearance of function and increment are quite arbitrary.
Okay, because I was gonna say, the way I'm reading this, and it might just be failure of my understanding, is I get why you did this, because we were taught that if you have a fee and you don't have fee within this will just become
Mhm.
whatever. But if we're deriving in terms of R, we should have R very.
I'm with you. I had the same confuse at my time, but when you are planning to take multidimensional integrals, in order to avoid meeting any elements, it's better like open and close the bracket, integral and then integration where we do. But it's only convention, and
So basically,
we don't violate any. So this phi part doesn't depend on r,
Yep.
so r can be interchangeable, either here or there.
it doesn't.
Okay, so
Do these limits change when you do them?
square of infinity.
Because it becomes
You should try.
0 and negative infinity, right?
Just do what you do. You're very close to the answer.
You can also just do it with no limits, Melody, and then once you have everything.
What can you keep minus in the exponential if it is easier? Like e to the power minus u. Like u equals r squared. But please keep going.
Okay. Everyone's too quiet.
No, we're following. I'm leaving you.
Mhm. So exponential to the power minus infinity. Will be
Wait.
so
Which is.
Oh, it's
square of infinity is infinity, and e to the power minus infinity is zero. Exactly. Everyone agrees? Okay.
Yes.
And yeah, e to the power 0 is 1. And you are keeping the minus here. And when you try this one, two minuses will cancel each other.
Oh, okay, and then, so this is that, so you need to take.
Perfect.
Oh,
So
0 squared. is 0.
plus 5 points to melody.
wow.
Yeah. Yep.
Good job.
Okay, so yeah, point. Mm, now we need to get can I erase it?
Yeah.
Okay. No,
No.
I hope it is recorded both in sound and in
Well, is your
Video.
thing, is your camera supposed to be pointing at the board?
invitation.
Or is it? Okay. Oh.
Oh, there is yes, we just practice patience and
I told you,
you don't need to watch, just give me a like and it's
Okay.
enough.
I'll like and subscribe.
Thank you. Okay, so my task is to erase as much as possible.
That's your way, no? I didn't really need for it to happen.
So there are no true
Okay, now you
changes,
can erase it.
but there are
Yeah.
I'm erasing.
Yeah.
Your glory is recorded.
I'm sorry, you read it down?
It's the.
The work that Melody wrote on the whiteboard.
Oh,
I was watching instead of writing it down. So I didn't-
So I will be doing a dumb thing. You can relax. I will rewrite what was in here. So psi x t integral d k square root sigma pi e to the minus sigma k squared over 4 e minus pi h bar x e to the minus pi h bar h bar squared h squared. Okay, and then I no, this way. Fine. Correct? More or less.
Correct.
So now we do know that the senior power will give us square root of pi. So we know how to take this integral. But now we need to reconstruct, to make substitutions, maybe more than one, to bring this one into what we need. And how do I interpret? And I may have discrepancy even from what I write, but at least I will try to communicate the idea. We'll try our best to finish in 15 minutes, but the same strategy applies to your homework. So, how do I, maybe I'm a little tired of too many symbols. So I can call it e to the power minus a capital K squared. Or even just plus and then redefine A as minus sigma divided by 4. Now, the first power k, so you can call it e to the power b k, and then b will be minus I h bar x. And then the free term, which will be, so factor can go outside, we do not count for it, and free, wait, did I lie to you? I did,
Uh-oh.
I did, and you didn't catch me.
Man,
Right.
not again.
So, the senior, and it is important, the senior power, which is second, happens in this integral twice. Once from expansion coefficient, from the initial coefficient, and another from what we derived last time, from the energy of the plane wave. So, the definition of this constant A should include minus sigma over 4 from here, and then everything except k squared in there. So minus I to m h bar t. Now it is correct. So we have A capital, B capital. Right? Right. Integral d A and return sigma divided by. It is what we need to find. It's a little easier. So I would write down this as a little dictionary, and then from now on I will forget about scientific meaning, about position, about time, and just work with this integral. We do know that if it would be only k squared, melody always can help us, and we all know that it is square root of pi. But how can we bring this integral into like standard?
Can we not? Because those are multiplied together, right? Can we not just do like exponential like rules?
Then how are you gonna compute the integral after you add them all together? You're gonna have a polynomial.
So I want to have maybe a very maybe different a,
What if we
and do not have k at all, right? And find this a. So I'll just bring another out of box idea, and then you can practice it.
would we not be able to just integrate them separately?
No,
because
it
they're
is the same function.
multiplied.
You can try. Right. So there are mathematical liberties to add or subtract the same function, the same number, divide and multiply by the same function, right? So what if we identify a full square, like k minus something? I believe you don't have to do it. And then rename this as a new variable.
Oh, so what you're saying is, okay, I might be interpreting this wrong. Are you saying that we have to combine them and then separate the like k squared minus k plus 0, and then, or no? Because that's what I'm thinking, is you would have ak squared plus bk. No, that wouldn't work. Never mind.
So I would like to propose a strategy where one can also submerge any constant under differentiation sign. Okay. And now we need to identify a full square.
Oh, completing the square. Yes,
Tell others what you
completing the square. So you would basically do k squared, a to k squared plus bk is equal to 0.
Well, don't you
But-
have to add?
Yeah, you have to add to,
You have to add some c to both sides, and then you can factor it into like a square
And then
term.
you can set, and then you can, yeah,
Okay, so let me try, and I apologize if any of you wanted to practice it yourself. I just to save time, maybe I know the answer a little bit bigger. But if your homework, you will practice it again, just for slightly different setup. So e to the power a squared plus b k, and I do want it to be equal to e to the power k minus something squared, and then some constant here.
okay.
So I do know an equation that a squared plus 2ab plus b squared equals, oh, plus here will be a plus b squared. Right? So what prevents me from practicing this little rule?
The fact that we,
We do not have a third term,
yes,
but
that's
we
what,
can practice mathematical liberties.
that's what.
We can
that's what comes out.
add and subtract. So let's first identify what will be our little a.
The
so
AK squared.
If this is a squared, then a, another substitution, a will be equal to square root of capital A times a. Right? If this term is 2ab, and we already identify what is our little a. So our little a is so k is already here. We multiply and divide by square root of a capital. We multiply and divide by 2. And now we can see that square root of a capital A is our little lowercase a, factor 2 is there, and everything else will be our lowercase b. So b lowercase will be b capital divided by 2 square root of a. Okay? And now we need, we can practice mathematical liberties once again and add and subtract b squared. So our b squared will be b2 square root of a squared b2 square root of a squared plus and minus. Right? I didn't violate anything. I just practice mathematical liberties. This is one big exponential. Here we have dk integral square root of sigma pi. So our psi. So now I can consolidate the first 3 terms as identified full square that contains our integration variable. And then this one b over square root of a everything. I need to correct one more mistake. Let's keep our k, our independent variable available. So let's remove this one from here, and then everything is good. Then I just got a little fear that our return will include integration variable. But if you define lowercase a as a square root of upper case a, then those are just constant. Okay, and then our thing will be k squared a b, and then k plus b squared. Okay, feel free to identify any errors I make them natural. So integral, the exponential, and then I'm just rewrite. Maybe I can immediately get lowercase k plus b squared. Now we can put dk there, and as a b squared, also b squared. And here we multiply by e minus b squared. So this is our price for being able to identify a full square. Is it? So sine square root of pi e minus b squared integral dp e to the power a plus b squared. Now, if I want to replace to take this one, didn't forget the minus somewhere.
It doesn't the minus become the negative?
No, I want to pick minus here.
Oh,
And what do I need to put it? Probably I can just swap sign everywhere. If I change sign here, then I just put plus. I think it will work this way. And I can track back later at home and check this teaching notes. Okay. So let's the goal is to replace this a k plus b into this new variable. So I play mathematical liberty. So I put a k here, and then I need to divide everything by a. And then I can freely add a constant under the derivative sign, right? I can put any constant under differentiation sign, like dx equals dx plus 1, because derivative of 1 is 0. So the function root sigma phi divided by a e to the minus b squared integral d a t plus b e to the minus e b t plus b squared, and then we can call it new variable u as a melody used for Greek psi that I was reproducing as a sound of bubbling water, right? And then I'm just rewriting square root sigma phi a e b squared integral d psi e to the minus d psi squared, which will reduce into square root of pi, right? So the integral itself is already taken, and the only non-trivial thing are the constants that we pull up front as a price for taking this Gaussian integral. And if we need to analyze the results scientifically, then we need, so this is answer, but it is not yet ready for analysis. To analyze it scientifically, we need to plug in these two definitions to translate from German to French and from French to English in order to understand what they're saying.
so you need to go back to the big B.
Yeah, plug in little a, little b, and then plug in big B and big A, and then investigate how the solution depends on x and time, how the future how the way function depends, will be changed in different position of space and different instant of time. I will quickly jump through slides, but they will show nothing better than we had here on the board. Everything is recorded, so if you look through it, the solution is there. Is there one thing? No. So the evening is free from that. Which one?
If that's really how you feel about it, I mean, we can,
No, the lab and MATLAB things are much easier than taking this integrals. So it is what the dictionary, the plan how to do it, and then discussions like Gaussian integral, implement in two-dimensional things.
Be watching football.
Here is the sort of price on the bottom.
you want to maybe collaborate. You
In
want,
watching football,
yeah.
you wanna go into Sam?
We're going to my, I'm gonna be at my permanent team.
So here are the things that we derived, and here
I spent the entire summer with you. I didn't see you guys.
Summer.
That's not true at all.
so and I'm just going back to see. Well, it shouldn't be started; it should be like finished for the actual. But meeting is done. Right? Meeting is done. Everyone is welcome to disconnect